Hi guys, my name is Taylor, and today I'm going to show you how to find the derivative of the inverse sine of x. Let's begin. So first we've got d dx for the derivative inverse sine of x. So this is going to require implicit differentiation. So if you haven't learned about that, then go check out another video on YouTube or on my channel if I've got one on implicit differentiation. So far this is my first video, so I don't have one yet, but just know that we will require that. Okay, so let's start with what we know. What is the inverse sine of x just by itself? Well, if we say that the inverse sine of x is equal to y, that's the same as saying that the sine of y is equal to x, right? Okay, so now what we want to do is we're basically taking the derivative of sine of y equals x. Okay, so we can write that out. We're taking d dx of sort of this whole expression, sine of y equals x. So what we're going to do is take the derivative of both sides of the equation, starting with sine of y. The derivative of sine is cosine. So we get a cosine y, and because we're taking the derivative of y with respect to x, we're going to need to use implicit differentiation here, meaning that we now need to write our dy dx, okay, using the chain rule. Okay, so that's what we have on this side. Also, if you haven't learned about the chain rule, I would highly recommend learning about that as well. Okay, on the other side, we just need the derivative of x. And because we're taking the derivative of y with respect to x, then that's just going to equal 1. Okay, so here's what we've got. Cosine of y times dy dx equals 1. So this is pretty simple. We're just going to divide over our cosine of y. So we've got d dx equals 1 over cosine of y. Now, it may be tempting to end here, but we're not quite done. We have the function in terms of y, but we need it in terms of x because our original question asked for it in terms of x. So how can we get our cosine of y to be something related to x? We're going to use a trig identity that you're probably familiar with, and that is cosine squared y. Normally you'd say x, but because we're using y, I'm going to write y here. Cosine squared of y plus sine squared of y equals 1. Okay, so that's the relationship that we have between y and potentially getting something in x. And I'll show you what I mean in just a second. So with this, we want to get the cosine by itself so that we can stick something right here. So what I'm going to do is subtract over the sine squared of y, and so we'll have cosine squared of y equals 1 over sine squared of y. Okay? Now we're going to take the square root of both sides. So we're left with cosine of y equals the square root. Oh, I apologize. I made a mistake. This is supposed to be 1 minus sine squared of y. Apologize for that. So now we have the square root of 1 minus sine squared of y. Okay, so that's nice. And again, it will be tempting to just plug that in here, but look, we still have it in terms of y and we need it in terms of x. Well, let's pay attention to this part right here, sine squared of y. Earlier, we defined that the sine of y is x, meaning that the sine squared of y is simply x squared. So we can rewrite this as cosine of y equals the square root of 1 minus x squared. And now that we have something in terms of x, we can plug that into our equation right here. So we've got d dx equals 1 over the square root of 1 minus x squared. And that, my friends, is the derivative of the inverse sine. Hope you enjoyed. If you did, please give this video a like and subscribe to see more videos of this in the future. And please let me know what topics you'd like me to talk on next. I'll talk to you later.